Good morning, grade 6. Welcome back to grade 6 mathematics class. Hope you all are doing great today. Let's learn about the place value of decimal numbers today. So we have already learned what do you mean by place value. So place value means the value of a digit based on its position or place in a number. So you see this place value chart here. Here, this is the place value chart for decimal numbers. So we know for a decimal number, there is a whole number part and there is a decimal or fractional part. And the whole number and the decimal parts will be separated with a decimal point. So towards the left of the decimal point, we have the whole number part, and towards the right of the decimal point, we have the decimal or fractional part. So in the whole number part, the place value system is the same as in the case of whole numbers. So to the left of the decimal point, you have the places ones, tens, hundreds, thousands and so on. Whereas to the right of the decimal point, you have the places tens, hundreds, thousands and so on. So when you are considering any particular place, the place value will be 10 times more than what is given in the right of it. That is, if you are considering the tens place, the value of the tens place will be 10 times more than the value of ones place. Same is the case in the decimal part. If you are considering the tens place, its value will be 10 times more than the value at the hundreds place. So let's see the place values once again. In the ones place, the value will be 1. In the tens place, the value will be 10. In the hundreds place, the value will be 100. In the thousands place, the value will be 1000 and so on. Now, coming to the decimal part. The value at the tens place will be 1/10 or 1 by 10. And the value at the hundreds place will be 1 by 100. And the value at the thousands place will be 1 by 1000 and so on. So let's see this with an example and make it more clear. You have a decimal number here. How do you rate this? It is 3207.109. So here I have placed the digits such that each digit comes under proper columns. So here the digit 3 is in the thousands column. So its place value will be 3 thousands or 3 into 1000, which is equal to 3000. Now what about the place value of 2? 2 is in the hundreds column and hence its place value will be 200s or 200. Now the place value of 0 is 0 tens or 0. Place value of 7 is 7 ones or 7. Now you have the decimal point here, and beyond that you have the digit 1 in the tens place. So can you tell me what is the place value of this 1 here? Its place value will be 1 into 1 tens. That is 1 into 1 by 10, which is equal to 1 by 10 itself. Now, what about the place value of the 0, 0, hundreds or 0 itself? Now, what about the place value of this 9? 9 is in the thousands place. So, its place value will be 9 into 1 by 1000, which is equal to 9 by thousands. So, I hope the concept of place value in the case of decimal numbers is clear to you. Now, we'll see how we can write the expanded form of decimal numbers. So, what do you mean by expanded form? Expanded form means you are expressing a number as the sum of the place values of its digits in order. So, here you have a number 152.76. We have to express this in expanded form. So, to write the expanded form, we need to know the place value of each of the digits in the number. So, let's see what is the place value of each of the digits in the given number. First, let's see the whole number part. So, here the whole number part is the number 152. So, what is the place value of each of the digits in the number 152? Let's see. 1 is in hundreds place. So, its place value is 1 into 100, that is equal to 100. Now, 5 is in tens place. So, its place value is 5 tens or 50. Now, the digit 2 is in ones place. So, its place value is 2. So, 152 can be written as 100 plus 50 plus 2. Now, let's come to the decimal part. The digit 7 is in the tens place. So its place value will be 7 into 1 by 10, which is equal to 7 by 10. So here you are dividing by 10. How many zeros are there in 10? 1 0. So just count one place from right to left of 7. So that would be here. Then put the decimal point there and it will give you the decimal number 0.7. Now what about the digit 6 in the number? 6 is in the hundredths place. So its place value will be 6 into 1 by 100, which is equal to 6 by 100. See here you are dividing by 100. How many zeros are there? 2 zeros are there. So you have to count 2 places from right to the left of 6. So 6 is a one digit number. So when you count 2 places from right to left, do like this, 1, then to count one more place, put 1 0 and then put the decimal point. And since there is no whole number part, you can put a 0 for the whole number part. So 6 by 100 is equal to 0.06. So these are the place values of the decimal part in the given number. So now let's write the given number in its expanded form. So we can write 152.76 is equal to 100 plus 50 plus 2 plus 0.7 plus 0.06. So this represents the sum of the place values of the whole number part, whereas this represents the sum of the place values of the decimal part. So this is how we write the expanded form of decimal numbers. I hope this is clear to you. Now let's see the representation of decimal numbers using square grids. You see this grid here, this is a 10 by 10 grid. This means that there are 10 rows and 10 columns. So you can see a square is being divided into 10 rows and 10 columns. So when you divide the square into 10 rows and 10 columns, how many smaller squares are there? There are a total of 100 squares here. So you can say each smaller square will represent a value 1 by 100. Now let's consider any one column. I am going to consider this column. So how many smaller squares are there in this column? There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 smaller squares in a single column. So can you tell me what is the value represented by a single column? That would be 10 into the value of one square. That is 10 into 1 by 100. So when you cancel out the common factors, you get this is equal to 1 by 10. Hence we can say the value of a single column is equal to 1 by 10. This applies in the case of a single row also. Each row will represent a value equal to 1 by 10. Now, what if I am shading a few squares of this grid and I am trying to find out the fraction? Now, look at this grid. I have got all the squares in this grid as shaded. Now, can you tell me what is the value represented by the shaded part? See, we know there are a total of 100 squares here and each column or each row will represent a value equal to 1 by 10 and there are 10 rows and 10 columns. So what will be the total value represented by this? So I am considering the case of columns here. So there are a total of 10 columns. So the total value will be the value of the first column plus the value of the second column plus the value of the third column and so on. And how many columns? 10 columns. And that would be equal to 1 by 10 plus 1 by 10 plus 1 by 10. That is 1 by 10 has to be added 10 times or 1 by 10 into 10, which gives you 10 by 10 and it is equal to 1. So that means in a square grid, if all the squares are shaded, that means it is representing one whole. You can see the whole grid is shaded here. So this represents a value equal to one whole. Now look at this picture here. Here I have got only a few squares of this grid shaded. Now what is the value represented by the shaded part here? How many squares are shaded here? We can see 14 squares are shaded here and each square has a value of 1 by 100. Now how do you represent the value of this shaded part? that would be equal to 14 into 1 by 100. Why? 14 squares are shaded here. The value of each square is 1 by 100 and that is equal to 14 by 100. So here you are dividing by 100. So there are 2 zeros. So count 2 places from right to left and put the decimal point and you get the value is equal to 0.14. 14 by 100 is equal to 0.14. So the value represented by the shaded part here is equal to 0.14. Now look at this picture. We have one hole here and 0.14 here. So the total value represented here is equal to 1 plus 0.14, that is equal to 1.14. So this is a way to represent decimal numbers using grids. So I hope this is clear to you. Now let's see how we can write decimals given the number names. So here the first example is 300 and 100. We have learned there are two ways to read decimal numbers or to write decimal numbers. For example, you are given the decimal number, this one. How do you read this? You can read this in two ways. One method is 2.75 and another method is 2 and 7500. That is the whole number read as it is and the decimal part read like a whole number followed by the place value of the last digit. So here are a few examples. Let's see how we can write the corresponding decimal numbers here. So the first one, 300 and 100. So the word and represents the decimal point. So what you see towards the left will be the whole number part. So 300, that is 300 and represents the decimal point. Then 100, that is the digit 1 in the 100th place. There is no digit in the 10th place. So we can put a 0 there and we can put a 1 there. So that would be 300 and 100. So the next one is 6 tenths. See, there is no whole number part given in the number name. 6 tenths means the digit 6 in the 10th place. And since there is no whole number part mentioned here, we can put a 0 for the whole number part, then put the decimal point and then the digit 6 in the 10th place. So this is the number name for 6 tenths. The next one is 1000 and 200. See the word and which represents the decimal point. So here we have the whole number part. So 1000, how do we write it? 1000, then for and we put the decimal point, then 200s, which means the digit 2 in the 100th place. There is no digit in the 10th place, so you can put a 0 for the 10th place, then the digit 2 in the 100th place. So the corresponding decimal number for the given number name is this 1000 or 1000.02, which is also read as 1200. So I hope this is clear to you. I want all of you to go through pages 98 and 99, which explain the topic we mentioned today. Then you can move on to page number 100. There you have exercise 7.1. All of you, please go through the questions carefully and work out the answers in your maths notebook. So that's all for today, children. We'll meet in the next class with a new topic. Till then, bye.